Okay, example 3, write an equation in the xy plane. So we have a physics question. So elliptical gears can be used to generate variable output speeds. After a 60-degree rotation, the equation for the rotated gear in the x prime y prime plane is as shown. Write an equation for the ellipse, so we know it's going to be an ellipse, formed by the rotated gear in the xy plane. So we need to write it in the xy plane. So let's have a look what we need to do. So to write, let's change that pen. So to write in the xy plane, so we need to use the equations. So x prime is x cosine of theta plus y sine of theta. And then we have y cosine of theta minus x sine of theta. So we need to substitute in what we know. So we're told is 60 degrees. So we know that it's going to be x cosine of 60. And the cosine of 60 is a half. So we're going to put in a half x. So half x. So this is y sine of 60. And sine of 60 is root 3 over 2. So this is root 3 over 2y. And then for our y, so this is going to be cosine of 60. So we've got a half y, and then it's minus sine of 60. So this is going to be minus 3 over 2. And this is x. So these are our formula that we need to use. Now we could write them just over 2. So next, we're going to substitute these into our equation, but we need to look at our equation first. So we have x prime squared plus y prime squared is equal to 1. And this is divided by 36 and divided by 18. So now we're like working backwards. So we want to look at the highest denominator, which is 36. And we're going to multiply through everywhere by 36. So if I multiply by 36, so this is going to, these are going to cancel out, and this will become 2, and then this will become 36. So if you rewrite that, x prime squared plus 2y prime squared is equal to 36. So we're going to use this equation. So we're going to substitute in our values. So I'll use this one. And we're going to substitute the values into this one. So we have x prime. So this is going to be, this is our x prime here. We're going to have a half plus half x plus root 3 over 2y. And this is squared. And then we're going to have 2 and this y. So our y value is going to be a half y minus root 3 over 2x. And this is squared, and it's equal to 36. So what do we need to do now? So we're going to rewrite these just over 2. So we're going to have x plus root 3y over 2. And this is going to be y minus root 3x over 2 squared is 36. And I'm going to distribute. or I'm going to use, looking at the first one, this is a plus b squared. So we can multiply this through. Just waiting for the internet to catch up. Okay, so x squared. So this is going to be x squared and minus, so it's going to be plus 2ab, so plus 2 root 3xy. And b squared is going to be plus 3y squared, and it's all over 4, because 2 squared is 4, plus 2, so it's going to be y squared. This time we've got a minus b, so it's going to be minus 2ab, so it's going to be minus 2 root 3xy, plus, and then 3x squared, also over 4, and this is equal to 36. So now we need to, so what I'm going to do, I'm going to multiply this side by 4, and I'm going to eliminate the 4 on the bottom. So I'm going to do 36 times 4, so this is going to be 144. And then, so we got x squared plus 2 root 3xy plus 3y squared. Just going to multiply at this as plus 2y squared. 2 times minus 2 is minus 4 root 3xy. 2 times 3 is 6, so plus 6. And now we need to simplify. So we have an x squared and an x squared. So if we add those together, that's 7x squared. And then we have a plus 2 root 3xy, and we have a minus 4 root 3xy. So this is going to be minus 2 root 3xy. And then our last term, so we have a 2 plus 2y and a plus 3y. So that is going to be plus 5y squared. So let's move this up. And this is equal to 144. So I'm just going to bring the 144 over the other side. And make that equal to 0. So we have our equation. And if we check, so this is a is 7. So b is going to be minus 2 root 3. And c is 5. So b squared minus 4ac. So b squared is minus 2 root 3 squared minus 4 times 7 times 5. Okay, so 12 minus 140. So we can say that it is less than 0. So it's either going to be a circle or an ellipse. So if b is not equal to 0, so b is not equal to 0, and a is not equal to c. So b is not equal to 0, and a is not equal to c. We know it is an ellipse. So we can just check this in Desmos. Okay, so if we look at the equation in Desmos, we can see that we have a rotated ellipse.